In this video, we're going to learn how to solve some basic exponential equations. We'll be looking at equations involving exponential expressions, and specifically, those exponential expressions will have the same base. It should make sense that if we have two exponential expressions that are equal to each other and they have the same base, it means that their exponents must be the same. What I mean by this is the following. If we have a raised to some power b and it's equal to a raised to some power c, then it must be true that the exponents are equal to each other. B must equal c. We're going to be using this fact to help us solve some basic exponential equations. Let's take a look at some examples. In example A, we want to solve the equation 7 to the power of 3x minus 1 equals 7 to the power of x plus 5. So our exponential expression on the left is equal to the exponential expression on the right, and they both have base 7, so that tells me that their exponents must be equal to each other. So all we have to do is set their exponents 3x minus 1 equal to x plus 5 to help us solve this equation. Now it's just an algebra problem. If I want to solve for x, well, I'll want to get all the x's on one side and move all the things that don't have x's to the other side. For example, I can subtract x from both sides. This gives me 2x minus 1 equals 5, and then add 1 to both sides. This gives me 2x equals 6, and then all we have to do is divide both sides by 2 to get x equals 3. So this is the solution to our equation. In example B, we have the equation 13 to the power of x squared is equal to 13 to the power of 3x plus 4. Once again, our exponential expression on the left-hand side is equal to the exponential expression on the right-hand side, and they have the same base. They're both base 13. So when this is the case, it tells us that their exponents must be equal to each other. So we can set the exponents x squared equal to 3x plus 4. Basically, we're transforming an exponential equation into an algebraic equation, and we know how to solve this algebraic equation. We can move everything to one side and then try to factor to solve for x. So let's move everything to one side. We'll subtract 3x and subtract 4. We end up with x squared minus 3x minus 4 equals 0. And now if we want to factor this quadratic, we need two numbers that multiply to negative 4 and add up to negative 3. Those two numbers would be negative 4 and positive 1. So our left-hand side here factors as x minus 4 times x plus 1, and this is equal to 0. Now, if a product of two things is equal to 0, that tells me that either the first factor equals 0 or the second factor equals 0. So we have either x minus 4 equals 0 or x plus 1 equals 0. On the left here, we can add 4 to both sides. We get x equals 4. And on the right here, if we subtract 1 from both sides, we get x equals negative 1. So the two solutions to our exponential equation is x equals 4 and x equals negative 1. Now, in example C, we have the equation 4 to the power of 5x minus 3 is equal to 16. This equation is a little bit different than our first two examples in that our right-hand side here isn't an exponential expression. However, we may be able to rewrite that 16 so that it becomes an exponential expression, and we can use the technique that we've used in our past two examples to help us solve this equation. On the left-hand side here, we have an exponential expression with base 4. Let's try to rewrite this 16 here so that it's also an exponential expression with base 4. 16 can be thought of as 4 squared, so we can rewrite our equation as 4 to the power of 5x minus 3 equals 4 squared. Now that we have exponential expressions on both sides and they have the same base, we know that their exponents must be equal to each other. We must have 5x minus 3 equal to 2. So we've transformed our exponential equation into an algebraic equation. And so we can solve for x by first adding 3 to both sides. This is going to give us 5x equals 5. Now let's divide both sides by 5, and that's going to give us x equals 1. And x equals 1 here is the solution to our exponential equation. Let's take a look at some more examples. In example D here, we want to solve the equation 2 to the power of x minus 5 equals 8 to the power of 2x plus 3. In this example, we do have exponential expressions on both sides of this equation. The only issue is their bases are not the same. On the left-hand side, the base is 2. On the right-hand side, the base is 8. So in order to turn this into an algebraic equation, we need to somehow rewrite this so that they have the same base. We can try to think, can we rewrite 2 as 8 to some power, or can we rewrite this 8 as 2 to some power? Well, we can rewrite the 8 as 2 to the third power. So let's rewrite our equation. We have 2 to the power of x minus 5 on the left-hand side, and on the right-hand side, we're going to replace that 8 with 2 to the third power, and we'll keep that in parentheses for now. And all of this is raised to the power of 2x plus 3. Next, what we're going to do is use an exponential property to help us simplify this expression that's on the right-hand side. Remember that we had an exponential property that says if I have a to the power of m and I raise it to the power of n, we can simplify this by multiplying the powers. We end up with a to the power of m times n. And this is essentially what we have on the right-hand side. We have 2 to the third power, and this whole thing is raised to the power of 2x plus 3. So we can simplify this by multiplying the exponents 3 and 2x plus 3 together. So we have 2 to the power of x minus 5 is equal to 2 to the power of 3 times 2x plus 3. Now to do this multiplication, we'll need to distribute the 3. So our equation is going to be 2 to the power of x minus 5 equals 2 to the power of 6x plus 9. Now we have an exponential expression on the left-hand side equals an exponential expression on the right-hand side, and they have the same base. They're both base 2. So their exponents must be equal to each other. We must have x minus 5 equals 6x plus 9. So we've now transformed our exponential equation into an algebraic equation. And now we can solve by subtracting 6x from both sides. This gives us negative 5x minus 5 equals 9. And add 5 to both sides. We end up with negative 5x equals 14. And then lastly, divide both sides by negative 5. We end up with x equals negative 14 over 5. So that is the solution to our exponential equation. Let's take a look at one last example. In example E, we have 3 to the power of 5x minus 2 equals 1/9 to the power of x minus 4. Once again, we have exponential expressions on both sides of the equation. However, their bases are not the same. On the left, the base is 3, and on the right, the base is 1/9. In order to turn this into an algebraic equation, we need to somehow rewrite things so that they have the same base. We want to think, can we rewrite 3 as 1/9 to some power? Or can we rewrite this 1/9 as 3 to some power? Let's try to rewrite this 1/9 as 3 to some power. When you have 1 over a number, you might expect that you have 3 to a negative exponent. But as an intermediate step, let's start by just rewriting that 9. We know that 9 is 3 squared, so we can think about this as 3 to the power of 5x minus 2 is equal to 1 over 3 squared to the power of x minus 4. Now remember, we have the exponential property that says that if we have a to the power of negative m, this is the same as 1 over a to the power of m. Now our 1 over 3 squared looks like the right-hand side of this exponential property, which means that we can rewrite it as the left-hand side. We can rewrite it as 3 to the power of negative 2. So our equation is going to look like 3 to the power of 5x minus 2 equals 3 to the power of negative 2, all to the power of x minus 4. Next, we're going to simplify this right-hand side using our exponential property here. If I have a to the power of m and I raise it to the power of n, we can simplify this by multiplying the two exponents. So this is going to be 3 to the power of 5x minus 2 equals 3 to the power of negative 2 times x minus 4. To multiply out this exponent, we need to distribute the negative 2. So we end up with 3 to the power of 5x minus 2 equals 3 to the power of negative 2x plus 8. Now we have exponential expressions on both sides of the equation, and their bases are the same, which means that our exponents must be equal to each other. So we have 5x minus 2 is equal to negative 2x plus 8, and we've now transformed our exponential equation into an algebraic equation. So let's solve for x now. We can add 2x to both sides. That's going to give us 7x minus 2 equals 8. We can add 2 to both sides. That gives us 7x equals 10. And then lastly, divide both sides by 7. We end up with x equals 10 over 7. And that's the solution to our exponential equation. So in this video, we learned how to solve basic exponential equations. As long as the bases of the exponential expressions are the same, we can set the exponents equal to each other and turn our equation into an algebraic equation.